In the last part of this session, we will have a look at one of the non-traditional method which can be used for integer programming problems, and it's known as simulated annealing. This method is a stochastic or probability based, and it is suitable for both linear as well as non-linear problems. It can also be used not only for integer programming but for real value or mixed integer type of problem. So it is a method which is very powerful and used quite frequently, especially for integer programming problems. It was developed in the year 1983 by Kirkpatrick, Gellert and Becci. It is inspired from the annealing process which is used in metallurgy. So there are different types of annealing processes. One of the annealing processes, essentially the annealing process, it hits the metal to high temperature and then slowly cools down. The slow is a keyword here. So by slow cooling, you give enough time for the internal microstructure to adjust itself, and as a result, the material impurities or defects, they minimize and you get a proper uniform structure. In terms of thermodynamic concepts, you can call that the material has reached, after annealing, a stage of minimum energy. The picture here shows an example of annealing process. So one of the annealing process is known as recrystallization annealing. So this is typically used after heavy forming operation on metals. So because of forming like plate rolling or tube drawing, the material microstructure or the crystal grains, they get highly distorted and stretched. By doing the annealing process, the crystal structure improves and you get a much uniform and better structure, and hence that particular product, for example plate or tube, can be subjected to further forming or machining operations with more ease than it would have been without the annealing process. So obviously one will think what is the connection between the annealing process and the optimization process. So that is what we will see next. The annealing process, let's see what is the goal of annealing process and how it compares with that of optimization method. So the goal of annealing process is to reach an ordered state with minimum energy level. So what do you mean by ordered state is that from a rolled plate which has got highly stretched particle micro crystal structure, you want to reach to a structure which is more uniform and more properly sized with less amount of residual stresses and less amount of defects. So thermodynamically it means that the material has reached a minimum energy level at the end of the annealing state. In terms of optimization, if you look into a parallel concept, is that we want to reach the minimum value of objective function. So we can have some kind of relation or analogy between the energy level, thermodynamic energy level of the material with the value of the objective function. So when you are doing optimization, you are minimizing the value of objective function, and in the annealing process, you are minimizing the energy level of the material. Now let's see the driving agent or the key parameter which govern the annealing process. The key parameter is temperature. So when you have the material at high temperature, the energy levels are very high. So the constituents of the metal, they have got high energy levels. The molecules can move at much faster rates, and they can move to a larger distance as compared to at a lower temperature. So by using the higher temperature, you are giving more chance for reordering or more chance for readjustment in the energy levels. In parallel, in optimization, we can consider this temperature as analogous to the degree of freedom which we are offering to the variables when you are doing the optimization, each of the variables you will be searching in your search domain. So in order to search, how much freedom you are allowing for that material, for that variable to search at wider spans of the search domain is what is we are looking at. So higher in annealing, the higher temperature gives the constituents a more freedom to move around and reach minimum energy value in order to get the total cumulative energy value low. In the optimization problem, we require an analogous parameter, or in the optimization method based on the annealing, we have a parameter which is related to the degree of freedom. And the performance controller, that how do you achieve the best annealing, is done by the rate of cooling. So the key concept in annealing is the slow cooling. So the cooling schedule, or the way you are cooling the material, decides what is the end product, the quality of end product that you will get. So if you do sufficiently slow cooling, you will get the product which is having the lowest possible energy values and more uniform structure. In optimization method, the analogous concept is that at one level, that is when you begin the optimization method based on the annealing, you will start with higher temperature or higher degree of freedom to the material, whereas subsequently you will keep on decreasing this freedom. So analogous to drop in temperature, which reduces the freedom of the molecules, here the freedom which is available to the variables to shift from one spot to the other spot is decreased as you move down. So in the optimization method, which is based on simulated annealing, in the beginning you allow lot of freedom for each of the variables to move around. So if you begin with a particular point, so let me draw, if this is my search domain, and if I start my variable at this particular location, so let's assume that it is a two variable problem for the sake of simplicity, x1 and x2. And if I start at this particular point, at the beginning of the searching, I will search at much wider points. So I will keep on searching from one point to the other point, and these points I am allowing lot of freedom. So as you can see here, the points which are being searched, they are wide apart from each other. So as a result of this, you will get a much more chance of finding the global optima, and you will not get stuck anywhere in the local optima for the problem. Once you have done initial searching and you have spanned lot of search domain, in the subsequent runs you will slowly restrict the freedom to the search space. So let's say after a lot of searching you have reached at this point. In the next cycle of the searching, you will not allow that much freedom to the point. So you will restrict the searching to a narrow domain and you will find new point. In the subsequent part, you will further restrict the search domain. So as a result of this, in the subsequent runs, you are likely to reach to a point which is the global minima to the problem. So this particular method is specially useful where the problem has got lot of local minima, and finding a global minima is a challenging task.